This video is on the objective determine the critical value or values of a one-mean z-test at a given significance level to define a rejection region. Alright, and this is number 2. Alright, so this is the second video on this objective that I've worked on with for you. So I'm just going to get right into it, and it won't take as long as the first one where I did a little more explaining. Alright, so this one's a question and also has an interactive part. You have to move some stuff around. So here, alright, so the mean math SAT score for seniors at Blue Moon High School is 560. An investigator believes that this score is different than the national average. So after obtaining all relevant data, she conducted a hypothesis test using a significance level of 5%. Determine the critical value or values for a one-mean z-test at the 5% significance level if this hypothesis test is two-tailed. Because remember, the belief here that the investigator is checking, the belief that this investigator is testing, is that this score is different than the national average. So the national average would be like mu, right? The average for the whole population is different, not equal to 560. All right. Now, if you recall from when we have a two-tailed test, let's get rid of this. When we have a two-tailed test, and it's a z-test, right? Because they said it was a z-test. We're going to be working with a normal distribution. You end up eventually looking at the standard normal curve, right? So z-scores, bell-shaped symmetrical distribution. Underneath the peak, is the z-score of the mean, which was 560. You would assume the mean was 560. That would have a z-score of 0. Right? Remember, the underneath the peak of the standard normal was 0. And then we're looking for, these rejection regions, critical values. Now, alpha, they said the significance level here was 5%. 5% or 0.05. Now, when you have a two-tailed test, right, and that was because the alternative hypothesis was that the mean was not equal to a value, not equal to 560, instead of being greater than or less than. A two-tailed test, these critical values we're looking for then are the following. There's going to be two of them, one on the right and one on the left. And I want the area beyond them. All right, so the area to the right of the right critical value and the area to the left of the left critical value, I want them to have a total of 5%. So this has an area of half of alpha, right? 2.5%, or 0.025. And same with this region over here to the left of this critical value. This has an area of half of alpha, or 0.025. So what we're looking for, right? These critical values that enter that are the boundaries of these rejection regions. I'm looking for specific z-scores. Now this positive one it's the z-score with an area of 2.5% above it, so 0.025. Z with a subscript of 0.025. Again, remember this means the z-score with an area of 2.5% above it. And then over here is just the opposite of that, so negative that value. Okay, so these are the critical values, right? And we can find these, from our table that they provided. Let's look for the special z-score. Right? Now look, the z-score with an area of 2.5% above it is this value right in the middle here, 1.96. So back on my paper, this z-score with an area of 2.5% above it is positive 1.96. That would be one critical value. And this z-score over here with an area of 2.5% below it would be negative 1.96. And both of those would be considered the critical values for this particular hypothesis test. Right. And it's that simple. Right, that's all that's being asked. Now they want us to move some stuff on this graph here. See this normal distribution. So I moved the blue dot here to the appropriate test. And we said it was, this would be if it's left-tailed. This would be if it's right-tailed. It's two-tailed. Right? Should have two halves of the rejection region, one to the right, one to the left. And then I need to move this purple dot to a point where the z-scores are in the proper place. Now we said, 1.96 and negative 1.96, not 2.576 and negative. So this is too far away. That's still too far away, those two critical values. There we go. A z-score of 1.96 and negative 1.96. This purple area is 2.5%. This purple area on the left is 2.5%, making a total of alpha, a total of 5%, the significance level. And we have our two critical values. And that's all we're asked to do here is move those dots around to draw the picture we need to draw, when we're talking about critical values and rejection regions. All right. And again, read through, right, the answer explanations. And if you got it right, you'll verify that your reasoning was right, and if you got it wrong, you hopefully can see where you got it wrong. So that way when you see another problem like that, hopefully you'll do better. Alright, so that's it. I've done a couple videos now on this objective, problems related to this objective. Hopefully these videos help you when you're working on this on your own. And thank you very much for watching.